This is my other project, which was the creation of the mobile app that enables you to log visual meteor data observation more effectively. So here are the other popular methods that are used, which most of them include the paper and a clipboard, paper roll, or something similar, and an audio recorder. But the problem with these methods is that like paper can get wet from the dew, and you always need some kind of red light with you, which can prove cumbersome in some cases. And in case of an audio recorder, you would need to re-listen to the footage and manually transcribe what you have said. And then for all of those methods, you have to reformat the data so it can be uploaded to the IMO. So difficulties can be off-putting for some new observers because it can be scary to them. This is an example of for Perseus, how much of the papers were used for just 3 observers over 3 hours of observations. So a proposed solution is a mobile app called MeteorLog that enables you to log your observations with that app. How it works, it's targeted toward also new and experienced observers. And thanks to the new IMO method of uploading observations, this app generates a CSV file, which can simply be dragged and dropped into the IMO website, and most of the data is already filled with that. So it was important that this app uses a dark theme with some red accent color so that it doesn't disrupt the eye's adaptation to the darkness. So also the app should work completely offline, since observations can be done in some remote areas with no reliable internet connection. And also, if you are observing in a group, this app can log data for multiple observers on a single device. So only one of those people needs to be the one who logs. And only currently active meteor showers will be displayed, since we don't want user from picking over 100 potential showers. And also, when observation period ends, the phone vibrates, so you don't have to check up on the screen every time to see how much time you have spent. For the technical implementation, I've used the Flutter framework, which means I can, with a single code base, build an app for both Android and iOS. There's no need to have separate projects for these 2 platforms. And also I've used the Meteor list from the IMO's website to see the names of the showers and their active periods, so I can determine what to show to the user in a given time of their observations. I've created an observer class that tracks separately for each of the observers their data and the meteors that they've spotted. And at the end of the session, this data is stored separately into CSV files for each of the observers. This is how a user interface looks like. So at the top, we have some basic setup of the session, like how many observers will there be, how long will the period durations last, which active showers do you plan on observing. And then according to that, this table is generated, which you then fill in with the observer's name. I've here used the center star instead of a reckless change in declination of the FOV, since it can be easier for new observers, so they don't have to remember reckless engine and declination. They can just use some of the recognizable night sky stars. And also, those familiar these users don't have to input limiting magnitude. They can just use the star fields and count the number of stars in them to get an approximate limiting magnitude. And when a session starts, this table is generated, which, when a meteor is spotted, you then check for each observer if it saw it. You, from the drop-down, select the shower that they think it is, and then you enter the magnitude of it. And you can now show the demo file, how the app works. Yeah, this is it. So you enter the number of observers. Among the drop-downs, you select the showers that you want, and just fill out this table with the names. Select from one of the stars the one that is closest to your center of the field of view. Enter the field of view's abstraction percentage, of course approximate, and enter the star field data. And when you do that, you just press start session, and a counter will show you how long have you been observing. when a meteor is spotted, you tick for each observer, and when you submit, the table resets and it is ready for submitting another meteor. And when the session ends, then the CSV files are saved on your device, and then when you return home, you just drag and drop them into the IMO's website. Close that. So conclusion, this app aims to serve both new and experienced observers as an alternative method of storing their visual meteor observations. Also, this can prove a lot more interactive and simple method for new observers, which they may find appealing. And for the next steps, this app previously had some of the bugs, so they would also need to be tested on a wider range of observers to see if there are any other bugs remaining, and also to see if someone offers some kind of an improvement in the form of a feedback, so it will be useful to update the app with some new features. Here is the repository with the app that I've developed, and also from this QR code you can download the latest version if you're interested. And of course, special thanks to the members of my Astronomical Society, Laura and Tony, for the app idea and their feedback on it. Here is also the same QR code. Thank you for your attention.
Do we have any questions? Yes.
Hello, thank you very much for your presentation. That's really, really interesting. But good tip to estimate the magnitude, the obstruction, and so on.
Yeah, for the, can we turn back? For the field number, since not all of the observers can know what that is, when they click on it, maybe it's not the most noticeable thing, but when you click on field number, it leads you to Dino's website where it explains.
I have a question.
Yes.
I have a question. Is there a way to use the telephone buttons on this thing as a fast? Otherwise, you have to go to see the field of your telephone, and if you are observing, it's faster than press a button, and then you can report what you're seeing. Do that.
So you mean like pointing the phone in the sky, or?
No. Just press the button, and then, like a reporter, you then take the information of the system.
But how would you select the shower that you approximated?
Well, that's why you have to.
Oh, okay, that could be done. Yes, that's a good feedback. Yeah. You also have volume up, volume down, so those could be key binded to certain operations. Yeah. Thank you. There.
Now, thank you for this, the work putting in such an app. I also, when visual observing, always use my iPhone. I would love it if you could implement, if it could also be voice operated.
Voice. So you mean that it can transcribe what you said?
Yes, exactly. Speech recognition.
But what could be the problem? I think that if you're in a group and a lot of voices are coming from multiple directions. But if you're alone, I think that could be the most useful.
Will there be any in-app purchases?
Maybe a donate button or some premium variant where it includes additional tips.
Thank you so much for
Thank
both
you.
of the presentations. Yeah, thank you.